Begin to record. All right, so welcome to this lecture. This is our lecture 4. And in this lecture, like I said, I'm going to introduce irrational numbers, though we did part of it in the previous lecture. So I'm going to introduce rational numbers, and then we also have some practical questions that we're going to solve under irrational numbers. Okay, so the first thing that we'll have to discuss is simply just the definition of irrational numbers, and then apart from that, there's also a part of SADS which I'm going to introduce to you. I think that should be in the next session that we're going to have. So tonight, maybe we may have 2 sessions. The part for irrational numbers, I think I'll put it alone. Then the part for SADS will also be independent, I think so. Yeah, so that at least it should cover maybe that part which there were some 2 sessions that we did not meet last week. Okay, so let us quickly get into details. So what is an irrational number? So the simplest definition of an irrational number is any number that cannot be expressed in the fraction form. So any number that you can't express in the form a over b is called an irrational number. So what are examples of these irrational numbers? So we have pi. Pi is one of the examples. And then apart from that, we also have other numbers that are irrational, like the square root of 2, the square root of 3. Yeah, so any square root of a non-perfect square, or a non-perfect square number, is called an irrational number. So what this means is that you can have, if you have the perfect squares that we have, we know them. We have 1, we have 4, 9, we have 16, 25, you have 36, 49, you have 64, you have 100, there's also 81 somewhere there. Okay, so these numbers that I've written here are called perfect squares because the square root of these numbers are definite. But any number that I've not written here,
sorry to disturb, but I'm unable to see your shared screen.
You're unable to see my screen.
Yes.
Then what's
It's just loading, saying you started sharing.
Even now you can't see?
No, I can't.
Maybe that should be a problem that side with network.
Okay, let me try leaving and then
All
let
right.
him back.
Okay, you can do so. All right. So this is what I'm trying to talk about. Yeah. So I was saying, any square root of a non-perfect square number is an irrational number. So for instance, the square root of 2, two is not a perfect square, meaning the square root of 2 is an irrational number. Square root of 3, irrational number. Square root of 5, irrational number. Square root of 6, irrational number. Square root of 7, square root of 8, square root of 10. So any square root of a non-perfect square is an irrational number. So these are what are known as irrational numbers. So the definition that I gave you is the definition for irrational number. That's the simplest. Yeah, so an irrational number is any number that you can't express in the form a over b. Okay. So let's proceed, and let's see how we can prove whether a number that you've been given is either irrational or not. All right, so this is what I was just talking about. A number, a rational number is a number in a decimal form. An irrational number is a number in a decimal form whose block of digits neither terminates nor repeats. That's the other definition of irrational numbers. Yeah, for example, you have this number here. So when you check the decimal places of this number, they are not repeating, they are not terminating. It shows that they continue going this side, but they are not repeating. Okay. Yeah, so we have other examples of irrational numbers. We have pi there, then we have the square root of 2, square root of 3, and square root of 5. So now, how do you prove that these numbers are irrational? This is where we're going to, this is what we're going to discuss in this lesson. So let us start with the simplest irrational number that we have. We have this square root of 2 here, and the question is, prove that the square root of 2 is an irrational number. How do you prove that? So we use a method known as the contradiction method. So before you can even start proving, you can first write your heading here, which is the title of, or simply just the method that you are going to use to prove. So you can say by, you can write by contradiction method. Let me write small letters rather. So you can say by contradiction method. So it's very important for you to specify which method that you are using. So now, by just looking at this statement that I've written here on the screen, you can see the word contradiction there. So what it means is that we are going to assume that this root of 2 is what? Is a rational number, because we know to say for anything to be called a rational number, it should be able to be expressed in a, you should be able to express it in a fraction form. So what this means is that we are going to say, assume the root of 2 is rational. So we are making an assumption that the root of 2 is a rational number. So if the root of 2 is an irrational number, somehow or along the process as we solve, we are going to find something that is going to contradict with the definition of a rational number. So let us now define what a rational number is. So what is a rational number? So a rational number is the number that can be expressed. So if we say the root of 2 is a rational number, it means that this root of 2 can be expressed in the form a over b, where a and b are members of what? Integers. This is how we defined a rational number. We said if any number is a rational number, it means that it can be expressed in the form a over b, where a and b are members of what? Integers. And this a and b should be what? Sorry, before we do that, there was a statement in between which we said b should never be equal to what? 0. What happens if the denominator of any fraction is 0? If you have any number divided by 0, the solution is what? Undefined. But 0 divided by any number, the answer is 0. So now, this is the reason why we're saying b should never be equal to what? 0. And the other statement, if you remember very well, on the definition of rational numbers, we said a rational number, for this fraction to qualify to be a rational number, a and b should be, A and B should be co-prime factors. Or what that means is that a and b, or this fraction a over b, should be in its lowest term, meaning there shouldn't be any number that should be, or rather that should go into both a and b. Yeah, so we say where a and b are what? Are co-prime factors. So if a and b are co-prime factors, meaning if this fraction is in its lowest term, that's the other meaning. It means that the fraction is in its lowest term. meaning there's no number that can go into this fraction. Okay. Or maybe should I say from the word prime? Yeah, maybe that's another way I can explain this. From the word prime, it means that this fraction only has two factors, one and itself, meaning there shouldn't be any other number that should be a multiple of this fraction. Oh, sorry, that should be a factor of this fraction. Okay. All right, so let us see. Let us see what next. So we say the root of 2 should be expressed in the form what? A over B. Okay, so now let us cross multiply here. So as we are solving, we are supposed to be on a lookout. We should be checking each and every step that we reach to see to it that we find one statement that is contradicting with one of these statements here. So the statements that we have here are that A and B should be members of integers. So if we discover that as we are solving here, either A or B is not an integer, then we can just end there and conclude that the root of 2 is not a prime, rather, it's not an it's not a rational number, but an irrational number. Yeah, so if we find any statement that is contradicting with either this statement here or this one here, we conclude just from there to say the root of 2 is irrational because because there's a contradiction there to say maybe A and B are not coprime factors, or B is not I mean B is equal to 0, or A and B are not members of integers. All right, so let's quickly do that. So here we're going to cross multiply there. So when you do the cross multiplication, we are going to have B times the root of 2. We're getting B root. Okay, before we cross multiply, I think that if I cross multiply and then raise both sides by the power 2, that will be a bit confusing to some. So before I do the cross multiplication, let me first get rid of the square root. So to get rid of the square root, I'm going to square both sides. So if I square this side and that side, this side I'm going to get what? 2 as the solution. And then on the other side, I'm going to get a squared over b squared. So when I do the cross multiplication here, I'm going to get a squared being equal to 2b squared. So this is what I'm going to get as the solution. So now if you check this, when I say 4 is equal to, if I say, okay, I want you to follow me properly here. So if I say 2 is equal to 3 times 2, I want you to look at this. Okay, so let's do this. This one. This one will be a bit confusing. I want something that will be a bit practical. Okay, let me just use symbols. I wanted to put 6 this side, but let me just use symbols for you to understand. Okay, so if you have, I want you to look at this statement here. I think let me use this same statement. If we multiply 2 times b squared, we are getting a squared. If we multiply 2 and b squared, we are getting a squared. Don't you think that these 2 can go into can go into a squared? Because if you look at this statement here, we know to say 2 times b squared, the answer is what? A squared. Don't you think that 2 can go into a squared, b squared times? In other words, what I'm trying to say is that if you divide by 2 on both sides, you're going to have a squared over 2. This side, you're going to remain with b squared. What this means is that if you divide a squared by if you divide a squared by 2, the answer that you're getting is what? B squared. So in other words, we're trying to say 2 is what? is a factor. We're saying 2 is a factor of a squared. 2 is a factor of a squared. Why am I saying that? It's because I know to say, for me to find a squared, I'm supposed to multiply 2 by b squared, meaning 2 can go into a squared. How many times? B squared. B squared times. That's what it means. All right, so we quickly move on. So having known that 2 is a factor of a squared, it is also mathematically proven that 2 is therefore what? Is therefore a factor of a as well. So if you have a statement like this, and you discover that this number here, which is multiplying with another number to get the number this side, as long as all the numbers here are perfect squares, it means that it simply means that the number that you have there is also a factor of this perfect square, which is this side. That's what it means. Okay, so now we proceed. So now to find, using this last statement that we have here, from this statement, we can also derive that if I want to find, we're saying 2 is a factor of a, it means that if I want to find a, I have to multiply 2 by a certain number, which is k. I'm sure, I don't know if you're getting this. Using this last statement here, we're saying 2 can go into a. So if 2 can go into a, I don't know how many times. So if 2 can go into a, let's write it here. So we're saying 2 can go into a. If it means that 2 is divisible by a. So now, since we don't know this number a here, this is the reason why I'm saying if I divide 2 by, if I divide a by 2, the answer that I'm going to get is what? K. But if I cross multiply here, I'm going to have a statement which is going to be a is equal to 2 times k, which is 2k. So this is where I've gotten this statement which I've written there. So I'm saying, since 2 is a factor of a, for you to find a, you have to multiply 2 by a certain number k. That's what it means. So from there, let us now quickly look at, let us now get this statement that we have here, which is a squared is equal to 2b squared. So while there's a there, I'm going to replace with what? 2k. So I'm going to put 2k while there's a square, or while there's a there, and then since a is squared, I'm going to square that, and this will be equal to 2b squared. And then if I do the simplifying, I'm going to get 4k squared being equal to 2b squared. So now I'm going to divide by 2 on both sides. So if I do the division, I'm going to get 2k squared this side being equal to b squared. Okay, b squared. Yeah, so this is what I've gotten. Let me just write it somewhere where to be visible enough. Yes, so when I divide everything there, I'm getting 2k squared being equal to b squared, which can also be written as b squared is equal to 2k squared. Okay, so now having written this statement here, the next thing that we have to write here, or the next observation that we have here, is that when you look at this statement and this statement, they are similar in the way they appear. So what it means that this 2 is also a factor of what? B squared. So you can say 2 is also a factor of b squared. And then mathematically, we know to say 2 is also a what? A factor of b. So now, if you read the definition of a rational number here, we said A and B are supposed to be what? Co-prime factors, meaning this fraction shouldn't have any factor. That's what it means. So now, from that, we can now conclude to say 2, we can just say 2 is a factor. 2 is a factor of both A and B, or A and B. And then we say this contradicts, this contradicts the fact. Okay, here is just a matter of English. You can use your own words to write these statements. Yeah, so we say this contradicts with the fact that A and B are co-prime factors. Okay. Yeah, so we say this contradicts with the fact that A and B are co-prime factors. Yeah, so we therefore conclude that, so we can say therefore the root of 2 is rational. Oh, sorry, is irrational. Or if you want, you can say therefore the root of 2 is not rational. Hence it is what? Irrational. Because there's a contradiction here. Hence it's what? Irrational. Hence it's irrational. So this is exactly what you're supposed to do. Yeah, so before we can proceed, I don't know if you have questions. Yeah, but it's better first.
Okay, for me, I think maybe when we move to the next example,
all right,
maybe I would get to understand.
Okay.
Yeah.
Yeah, but for these questions, that's why I never wanted us to do them in the previous session. Yeah, so for these questions, you mostly understand if you watch the video maybe 2 or 3 times. Yeah, otherwise, if you just getting it from the first hand, I don't know how you call that. Yeah, it becomes a bit confusing. But if you watch the same video 2 or 3 times, I'll actually send you videos where I solve these questions. I think these different types of questions of how you can prove that any given number is either irrational or rational. Yeah, so I'm going to do that immediately after the session. Okay, let's see the next example. So this is what I was just trying to explain. Okay, so this example is in the handout, which I believe you have. Okay, this is a contradiction because we said P and Q have no common factor. So in this, in your handout, they used common factor. It's just the same as co-prime factors. Yeah, so that's what it means. It's almost the same. They have the same meaning in short. Okay, let's try to look at this other question here. So this one is also similar to what we've just been to what we are just from doing. So solving this one, you can solve it. There are actually 2 methods that you can do. You can use. So remember, we've been asked to show that 1 plus the root of 2 is irrational. So if you've been asked to show that this looks like this or this is like this, it means that the thing that you've been given is actually okay. In other words, let me just go straight to the point. So in other words, we already know, or they already know, to say this is an irrational number. This is an irrational number. They just want you to show that it's an irrational number. So now how do we do that? So first of all, we make an assumption, or before we do that, we first have to write the title of the method that we're going to use. So even this one, we're going to use what? Contradiction method. So we say by contradiction. So we say by contradiction, the contradiction method. So we say by contradiction method. Yeah. So then the other thing that we need to do here is making an assumption. So we assume that okay, so I'll say the first thing that we do is to make an assumption. So we assume that 1 plus the root of 2 is rational. Yeah, so like I said, there are two ways in which you can solve this question. So the first one is this same one, which is similar to the one that I showed you in the previous slide. Yeah, on the previous page. Yeah, so it's similar. And then the other method that you can use to prove that this is irrational, it's also by contradiction method, but what you can do is you first prove that the root of 2 is irrational, and then by concluding, or rather when concluding, you simply just say, when concluding, you simply just say the addition of a rational number and an irrational number results into an irrational number, and hence 1 plus the root of 2 is irrational. Yeah, so the second method is somehow a bit simple because what you just need is to prove that the root of 2 is an irrational number. Then after proving that, you conclude by saying the addition of, if you remember the rules that I showed you on irrational numbers in the previous session that we had, I said the addition of a rational number and an irrational number gives you what? Gives you an irrational number. Hence, 1 plus the root of 2 is what? Is irrational. That's what I mean. Yeah, so let's go by the method that I'm from teaching you. So using that method, we can also prove that 1 plus the root of 2 is irrational. So now how do we prove that? So if this is rational, if we make an assumption that this is rational, means that this 1 plus the root of 2 can be expressed in the form a over b, where a and b are members of what? Integers. And then they are members of integers. And then apart from that, we know to say b should never be equal to what? 0. And a and b are what? Are co-prime factors, or they have no common factor. Yeah, so that's what it means. So from there, we get this same statement here. So we are going to have 1 plus the root of 2 being equal to a over b. So we take this one to the other side of the equal sign, and we're going to have the root of 2 being equal to a over b. And then we say minus 1. So this other side, we can find the common denominator. In other ways, we can make this expression as a single fraction. So we have the root of 2 being equal to, we have a minus b over b. So we can say let a minus b be equal to what? D. So that we
Sorry,
have the
can
root
you
of
ask
2.
the other person to mute their mic? Sorry.
Okay. So I was saying, I'm sure you've understood up to this point. Yeah, so I've just said let a minus b, which is just the numerator there, to be equal to d. And this will now be equal to, the root of 2 will now be equal to d over what? Over b. So from there, what we just need to do is to proceed with the steps that which I showed you on the previous slide. So what this means is that we're going to square both sides of the equation. So when you square both sides of the equation, we're going to have this side, we're going to get 2. And then on the other side there, we're going to have d squared over b squared. Then from there, we do the cross multiplication there so that we have d squared being equal to 2b squared. Yeah, so after doing that, from here we can conclude to say 2 is what? Is a factor. So I'm just going through the same procedure that we had in the previous session. 2 is a factor of what? Of d squared, and hence 2 is also a factor of d. So from there, we can say, for us to find d, we have to multiply, for us to find d, we have to multiply 2 by a certain constant k. And we can get this same expression and replace it there. So when we replace it there, we're going to have d, we're going to have something like this. When we replace it there, we're going to have 2k squared being equal to what? 2b squared. So the link is about to end. When it ends, you should all join using the same link that I sent so that we proceed and finish up the remaining questions. So we have 2k squared. When you simplify this, you're getting 4k squared being equal to 2b squared. So here I'm going to divide by 2 on both sides so that I get my solution to be b squared being equal to 2k squared. Okay. So now from here, the next thing that we need to do is to observe what is happening here. And you can say 2 is a factor of what? 2 is a factor of b squared. And the same 2 is also a factor of b.